Now we're going to look at exponential equations. So an exponential equation is an equation where the variable is in the exponent. So for example, 2 to the power of x is equal to 16. If we were going to solve for x, well, we know that 2 to the power of 4 is equal to 16, so x is just equal to 4. That was a fairly simple one, but they get more complicated. And there are three main methods for solving exponential equations. One is by writing both sides as powers of the same base. That's the one we're going to look at in most detail in this video. You can also solve them by graphing, which we'll look at briefly, and using logarithms, which we will look at after we've introduced that concept. So first we're going to solve for x by writing both sides as powers of the same base. And the principle that we're going to use is that if two sides of an equation are equal, if b to the power of x is equal to b to the power of y, and the bases are equal, then that must mean that the other part that's left over, the exponents, must also be equal as well. If b to the x is equal to b to the y, b is obviously the same on both sides. That means that x has to be equal to y. So we're going to write both sides as powers of the same base. Here we have 2 to the power of 3x minus 1 is equal to 16. We're going to leave the left side the same, and we're going to write the right-hand side as a power of 2, because we've already got a power of 2 on the left side. So 16 is equal to 2 to the power of 4. Now we're in this kind of situation. If 2 to the power of 3x minus 1 is equal to 2 to the power of 4, then the exponent, 3x minus 1 on the left side, must be equal to the exponent on the right side. So 3x minus 1 is equal to 4. We've essentially let the bases drop off here. We're just looking at the exponents. Now we solve like any other algebraic equation. So 3x is equal to 5, and x is equal to 5/3. So we solved it by letting the bases be, by writing both sides as powers of the same base. We could also have solved it by graphing, like graphing on a graphing calculator. If we were going to do that, we would graph the left-hand side as its own function. Y is equal to 2 to the power of 3x minus 1, and we would graph the right-hand side as a separate function, y is equal to 16. This is going to be a horizontal line. And you see the results at the right here. Here's the graph of the left-hand side, here's the graph of the right-hand side. And this approach is very similar to how you would have solved linear systems by graphing in a previous course. Then what you do is you look for the point of intersection. The graphing calculator will tell you the point of intersection is this rounded to some number of decimal places, comma 16. And this decimal here is an approximation of 5/3. So that means the two graphs intersect when x is equal to 5/3. That means that the left-hand side is equal to the right-hand side when x is equal to 5/3. It amounts to doing the same thing. So we can solve by setting both sides to be powers of the same base, or writing both sides as powers of the same base, or we can graph the left side and graph the right side as separate functions and look for the point of intersection. Let's do another example for writing both sides as powers of the same base. Same thing here again, we're going to leave the left-hand side as it is, and we're going to write the right-hand side as 5 to the power of 3. Now again, the bases are the same, the whole sides are the same, that means the exponents must be the same, so x squared plus 2x has to be equal to 3, and now we solve as a quadratic, a little bit more complicated, but not much really. Move the 3 over, factor, and that means that x has to be equal to -3 or +1. Same thing. Let's do one more example. In this case, it looks a little trickier because 32 is not a power of 4, but we can write both sides as powers of 2. In this way. Now remember that when you raise a power to a power, you multiply out. So 2 to the power of 2x plus 2, don't forget to distribute, is equal to 2 to the power of 15x minus 20. Now we can drop the bases. 2x plus 2 is equal to 15x minus 20. 13x is equal to 22. And x is equal to 22 over 13. So that's solving by writing both sides as powers of the same base.